Hello everyone, today we're going to resolve the LeetCode daily question number 3392. Count subarrays of length 3 with a condition. So it is an easy question where we're given an integer array nums and we should return the number of subarrays. It's a subarrays contiguous non-empty sequence of elements within an array of length 3, such as the sum of the first and third numbers equal exactly half of the second number. So we have a few examples where nums represent 1, 2, 1, 4, 1, and output only 1, as it is only subarray 1, 4, and 1. Let's say exactly 3 elements, where the sum of 0 of 2 elements 1 and 1 equals the half of the middle part, equals half of 4. Nums 1 1 doesn't fulfill our condition and return 0. So constraints are pretty small, so as we understood that, we can use brute force approach. And I would like to start with a good story about how we can resolve it in two ways. So, in the bustling city of Synergy, two apprentices, Jay and Patty, set out to master the art of pattern recognition under the mentorship of great teacher. Their task echoed one of the 7 habits of highly efficient people, begin with the end in mind. So they need to count every trio of steps in grand halfway, such that first and third steps add up exactly to half of the middle step's weight. So J trust habit 4, think win-win, and tried every possible trio one by one, ensuring no possibility was missed. Patty embraced the habit 3, put third things first, and realized that every window always spent 3 steps. She could slide her focus along the halfway, check the first and third weight, then move her window forward. No backtracking required. So by combining these habits, truthfulness from Jay and efficiency from Patty, they discovered two completely method that both achieve the same goal. So if you understand J is our JavaScript, we will use brute force algorithm, and we just check each step starting from 1 and 1, then adding 1 to another value, 3 on step 3, and compare it to the value in the middle part. So we start with declaring our initial count, which will be equal 0. So we understand if we cannot find a value, we will return 0. So we will return our count. Then we look for int of I, which equals 0. I will be less than nums length minus 2. Then we increment I. After that, we will make our check. So if condition nums I, number in the first position, plus nums I plus 2, number in third position, multiplied by 2, equal nums I plus 1, then our count will be incremented by 1. Here we can easily change this condition, for example, like representative of, we can remove multiplying by 2 and replace this with nums of I plus 1 divided by 2. So both of them work in the same way. Let's run our test and let's submit. And I see brute force approach the most efficient way to resolve this. So the next we will look for more original way, not solution, description. So the next way will be using sliding windows. So in sliding window element, our idea will be to create a window that we will slide through arrays, as we understand that we need to keep track of these elements left and right, and check the condition if the middle one equal half of the middle one equal the sum of the first one. So we start with our count, return count, then we declare our left and right boundaries should be equal 0 and equal 2. Now we will run while loop where our right boundaries less than len of nums. We will check if nums L left position plus nums R right position, so it's the third element and this the first element, multiplied by 2 equal to nums L plus 1, our middle element. If yes, count will be incremented by 1. And then we will increment our left and our right boundaries by 1. It will be slightly complicated, but it will help if, for example, we have bigger constraints to resolve this issue. So as constraints small, the brute force approach will be most likely more efficient. As you see, when it's only score 58, the brute force score 100. But again, if constraint will change and become more complicated, we will need to think about optimization. As for now, both of them run on the space time complexity of O big O of n, as we check loop only once. There will be slightly difference compared to brute force approach, as here we calculate values more often than compared to Python version where we just slide the window, but generally it will be the same. The same goes for space complexity. We only have fixated variable, then the space complexity is constrained. It will be big of n, big of 1, so it's the same all the time, and wouldn't change if the constraint of nums change. So here the main idea in our two methods is to balance truthfulness and efficiency, that teach us that understanding a problem deeply, a habit 5, seek first to understand, then to be understood, empowers us to choose the right tool. Whenever it the careful scan of brute force or the streamlined glide of sliding window, ultimately true mastery lies in applying the right habit at the right moment. And as we see, the most efficient way to resolve the problem with small conditions will be the most simplest way, the brute force approach. So thank you for your attention. If you have any question, feel free to leave them down below. Bye.